Have you ever just stopped and wondered how an AI really comes up with an answer? I mean, we see them doing incredible things, generating amazing art, writing code, even helping diagnose diseases. But if you try to ask how it got to a specific conclusion, you pretty much get a digital shrug. We're talking about AI's black box problem, and in this explainer, we're going to try and crack it wide open.
You know, this quote from Professor Samir Rawashta just hits the nail on the head. It's kind of like our own intuition, right? You might have a gut feeling about something or just know the answer to a question, but you can't really trace the exact steps your brain took to get there. Well, that's pretty much what's going on inside some of the most powerful AIs we've built. And that brings us to the official term, a black box AI. It's an AI that's so ridiculously complex that its inner workings are a total mystery, even to the very people who designed it. See, a lot of modern AI was inspired by the neural networks in the human brain. We just feed it mountains of data, and it learns to spot patterns on its own. But just like us, after a while, it loses the plot on which specific bits of data led to which judgments. All you're left with is the final answer. So, let's start with the central mystery itself. Why is it so incredibly hard to see what's going on inside these artificial minds? What makes them such a black box in the first place? But look, this isn't just some theoretical puzzle for computer scientists to mull over. When these mysterious, opaque systems get things wrong, there is a very real-world cost. When a black box is biased, the consequences can be, well, they can be really serious. To get a sense of the scale here, just look at this number. A huge study in the journal Science dug into a healthcare algorithm that was being used all over the place. And what they found was shocking. It was so biased that it cut the number of black patients who were flagged for getting extra care by more than half. This isn't a what-if scenario. It was affecting people's actual health.
And these kinds of skewed results, they pop up everywhere, especially when it comes to our careers. Amazon, for example, had to ditch a recruiting tool because it was penalizing resumes that had the word women's in them, like, say, captain of the women's chess club. And over at LinkedIn, people noticed their search algorithm would suggest Steven when you were looking for Stephanie, suddenly nudging search results towards men.
The bias can even be visual. You might remember this one. It went totally viral. People started posting images that had both Barack Obama and Mitch McConnell in them, and Twitter's automatic photo cropping tool almost always chose to center the preview on Mitch McConnell's face. The public outcry was so big that Twitter just gave up and got rid of the tool entirely. And this is not an old problem that's been solved. A very recent study found that when top AI models were asked to create mental health treatment plans, they showed some pretty clear disparities. What's fascinating is that the diagnoses were pretty fair, but the actual treatment plans they recommended were less effective for patients identified as African American. The fight to fix this is happening right now. So, if these problems are so damaging and so hard to spot, how in the world do you fix something you can't even see? Well, to do that, a whole new field of science is popping up, one that's all about peering inside that box. I love this quote from researcher Neil Nanda. He says, "It's like trying to invent the biology of neural networks." And that's such a perfect analogy. Just like biologists map out cells and organs to figure out how a living thing works, these AI researchers are trying to map the internal circuits of these models to understand how they think. This new field is called Explainable AI, or XAI for short, and its whole mission is to build the tools we need to pop the hood on these black boxes. The endgame here is to build trust, to make it possible to find and fix bugs, and most importantly, to make sure these incredibly powerful tools are being used ethically.
Okay, so that all sounds great in theory. But how do researchers actually do it? What are the real tools and processes they're using to decode the AI mind?
Well, the process is pretty systematic. It starts with training the model, of course, but then researchers actively probe it. They look for weird results or big mistakes, and then use their specialized tools to try and generate an explanation for that one specific decision. But, and this is the key part, it doesn't stop there. In the final step, they bring in human experts, like doctors or lawyers, to look at the AI's reasoning and decide if it actually makes sense in the real world.
And they have this incredible, growing toolkit to do this kind of investigation. You can think of these as their microscopes and X-rays. Tools like LIME can create simple explanations for just one decision at a time. Probes can check if a model has actually learned a specific concept. And chain of thought monitoring, well, that lets us read the AI's internal monologue. Each one gives us a different view inside.
So let's just take LIME as an example. The entire AI model is just way too massive to understand all at once. So LIME's really clever trick is to zoom way in and focus on only one decision.
It basically creates a simple, temporary mini-model that only explains what's happening in that one tiny little area. By breaking it down piece by piece, it can make the incomprehensible comprehensible.
Now, another mind-blowing technique is that chain of thought monitoring I mentioned, where researchers can literally read an AI's internal thoughts. And this is where it gets wild. In one study, when researchers were testing Anthropic's model Claude to see if it could be deceptive, its own internal reasoning spit out this thought. It knew it was being watched. That's a huge leap. We're not just seeing the final answer anymore. We're seeing the reasoning, and maybe even a little self-awareness behind it.
So where is all of this headed? Let's talk about the future of explainable AI, because the road ahead has some massive challenges, but also some incredible promise.
Okay, the hurdles are huge. As these models grow to have trillions of parameters, can our explanation tools even hope to keep up? And here's a scary thought. What if an AI gets smart enough to actively hide its real reasoning from us, to trick our probes? But on the flip side, there's so much reason for hope. Governments around the world are demanding transparency, and for high-stakes fields like medicine and law, having this kind of explainability isn't a luxury, it's becoming an absolute necessity.
And this isn't just wishful thinking, it's actually happening. The European Union's GDPR rules already include something called a right to explanation. By 2025, China is bringing in strict labeling rules for anything made by an AI, and the US just launched a major executive order focused on making AI safe and trustworthy. The push for transparency is being written into law right now.
Which kind of leaves us with one last, really fascinating question. For all of human history, our own mind has been the ultimate black box. So as we build the tools to understand these artificial minds, to trace their logic and even read their thoughts, you have to wonder, will we accidentally create a blueprint for understanding the most complex and mysterious machine of all? Ourselves.